Now, if the person swims across, this girl swims across, and now the current's going to move her. All right? So she's going to go somewhat up, but she's also going to go somewhat this way, correct? All right, now, if she's going on that line, so if I'm standing over here in this area watching her swim, I'm going to see her going across the river, but I'm also going to see the current moving her in this direction, right? So she is going to go, is she going to go further? Is she going to go the same distance? Is she going to go a shorter distance? She's going to go further, all right? So is her speed going to be slower, faster, or the same?
Faster.
Her speed, according to this guy, this frame of reference down here, is going to be faster, right? Because you're going to combine her speed with the speed of the current, correct? Right? Okay, so if, I don't need it, but if I wanted to find out what her speed was with the current, how would I find that out?
Cosine.
What would I do?
Cosine law.
Cosine law? I could, but I have no angles yet. What would be an easier way to do it?
A squared plus B squared.
A squared plus B squared equals C squared, right? Because I have a right angle. I have a right angle. So I do have one angle, correct? So that's how I would find out how fast she goes. All right, so you're saying that she's going to swim farther, but she's going to swim faster, so the time is going to be slower, faster, or the same. It's going to be the same, right? Further distance, faster swimming, same time. Agreed? Okay. Let's find out then, how do I find out the distance she ends up down shore from where she started? How would I find that distance out?
50 times 0.8.
0.8 meters per second is the speed of the current, right? And she's swimming, the current's pushing her at 50 meters per second. Okay? So how far down shore did she end up?
40 meters.
40 meters. Okay? Now what if she wanted to swim directly across and not end up down shore? What would she have to do then?
Swim at an angle the other way.
Okay, so let's draw that down here now. So now I'm going to swim that way into my current, correct? Okay? So she's still going at 1.4 meters per second, right? And then it pushes her back this way so that she can end up straight across from where she started. Okay, so this is 0.8 meters per second. Now, again, if I'm standing down here watching this, right? Okay, if I'm standing down here watching this, what's happening? She's swimming out here, and then she gradually moves over to here as she gets up to there, right? That's what it's going to look like. So how fast is she going across then? Is she going the same speed? Is she going slower or faster than what she actually would be swimming with no current?
Slower.
She'd be swimming slower, right? She's going into the current, which is going to slow her down. So to get this velocity, as to how fast it's going to appear that she gets across, right? I've got this squared minus this squared equals that squared, right? So then I would get my velocity here, and it's still 70 meters, and then I would find out. Now, would her time be faster, slower, or the same as what she had before? It'd be slower, wouldn't it? Right? So she would go more than 50 seconds to get across there. Does that make sense to everybody? That's a standard question. That's all I can ask of you in this question. Okay? So, I'm going to do another question that's going to be very, very similar to this question, with one exception. So, let's talk about it. Let's look at question 27. Now, kid's pedaling a bike along the sidewalk. Wants to throw a newspaper onto a porch. Okay? So, he's pedaling along the sidewalk this way, right? The porch of the house is somewhere over here. Everybody get that so far? Okay. So, here's straight across from it, right? If he wants to land that paper on the porch, Okay, if he's pedaling his bike and he throws the paper from directly across the porch without stopping his bike from moving, where's the newspaper going to end up?
To the right of it.
To the right of it, correct? It's going to end up over here. Why is it going to end up over there? Okay, how fast is he pedaling his bike?
4 meters per second.
4 meters per second. How hard does he throw the paper?
6 meters per second.
Right? So with the speed of his bike and how fast he throws it, okay, it's not going to end up on the porch, is it? So what's he going to have to do in order to have it end up on the porch?
Throw it before the porch.
Throw it before the porch and then have it come across. Okay? So he throws it straight over here, and the speed of his bike is going to carry it to the porch, which is right there. So he's going to have this. Okay? How fast is that paper going to be moving?
7.211 meters per second.
7.211 meters per second?
Yeah.
Okay? Because you got to take into account how hard he throws it. All right? And then you got to take into account how fast he's pedaling his bike, because it has both speeds involved in it, right? Okay. So boy throws paper sideways onto the porches of his customers while riding his bike along the sidewalk. Sidewalk is 15 meters in front of the porches. The boy throws the horizontal speed of 6 meters per second and rides the bike at 4 meters per second. With what horizontal speed do the papers actually travel? So there it is. There's the horizontal speed that they actually travel at. Right? How far in advance of the porch should the boy throw the paper so that it lands on the target? Okay, so this again is a similar question. So what do I want to find out? Well, in this question, I found out how long it was going to take by taking this straight across distance. How fast she swam and how far it was. What am I going to use to find out how long it takes to go from here to here? Do I know how far the sidewalk is to the porch? How far is it?
15 meters.
So that's 15 meters right here, is it not? Straight across? So therefore, the time it's going to take is going to be based on the speed at which he throws it at, correct? And the distance it takes to go straight across. Same thing here. Now, this one I wanted to find out how far downstream he was. This one I just want to find out how far away from the porch he has to throw it. So doing the same thing, how do I find out what that distance is?
4 times 2.5
4 times 2.5
is 10.
is 10 meters. So he's got to throw it 10 meters early, because it's going to go up and it's going to go over. She swims up, the current moves her over. Exact same question. Exactly the same. Now the third part of that question is, if he wants to throw the paper, when he is directly across from the porch, at what angle to the sidewalk does he have to throw it? Well, what did I do here? She wanted to end up directly across. So where did she have to swim? Into her current. He wants to throw the paper from directly across. Right? So here's my porch. Here is him. Right here. Where does he have to throw it? Up here. And then the speed takes him to here. Gets you there. Right? So I have a velocity of 6 meters per second here, correct? I have a velocity of 4 meters per second right here. So what is it asking? In this question, it asked you what angle to the riverbank. That was that angle right there. In this question, it says what angle to the sidewalk. That's that angle right there. But I can't get that angle unless I get this one or this one. So let's find that guy. How do I get this guy? Where is that in relation to x?
Opposite.
Opposite. Where is this in relation to x?
Hypotenuse.
Hypotenuse. Opposite and hypotenuse is what?
Sine.
Sine. Sine 4 divided by 6. Second function sine, because you're finding an angle, correct?
41.810.
810. So that's the angle which he's got to throw it compared to where he wants it, right? So how do I get this angle right here?
Subtract from 90.
From 90. That's right. So take that angle, subtract it from 90. What do I get?
48.19.
There's the angle with the sidewalk. These two questions are exactly the same. Exactly the same. The difference is his speed that he rides the bike is the same as what the current does in the water. You guys get that? So now I've given you two questions that you're guaranteed to see that are exactly the same. Does anybody have questions about either one of these? Marshall.
Just for the second one, the answer in the book is the first angle, not the
Is this?
second. Yeah.
Okay, so it depends what it's asking here. If he waits until he's opposite, at what horizontal angle with respect to the sidewalk will you have to throw the paper to hit the porch? Okay, so what number is that? 28?
27.
Oh, never mind. I was wrong.
I see 48.
Yeah, never mind.
You good, Marshall?
I thought I read 42.
Okay, so you're gonna have 70 questions on the test. There's 2 of them. All right? You had one of these questions on your worksheet, right? So you know that it's coming. Is there anything that we don't understand about either one of these? Okay, so my question to you is this. How do I get the time in each case?
Distance.
What velocity am I talking about and what distance? No?
Delta distance, delta velocity.
Yeah, but where are they located in this question? What do I do to find them? Okay, the distance is always going to be what? Straight across, correct? Straight across, right? It's always going to be straight across. So you need to know what the velocity is straight across, and that will give you the time it takes. And that time doesn't change for the diagonal because you're moving faster and going further, but maintaining the same time. Right? Okay? Any other questions about this? All right. Okay, so now let's get into the airplane stuff. A pilot maintains a heading due west with an airspeed of 240. After flying for 30 minutes, he finds himself over a town that he knows is 150 kilometers west and 40 kilometers south of his starting point. All right, what is the wind velocity? Okay, so we know that the plane's velocity is what?
140 kilometers.
240 kilometers per hour, and it's west, right? I want to know what the wind's velocity is. I also want to know what the ground speed is. I don't know either one at the moment. So what is the one that I can find right away and why? What can I find right away? What else are you given in this question?
Where
Where he is?
you have the, like, what the wind speed, like the quantities of the wind speed, 150 and 40.
That's not the quantities of the wind speed.
Yeah, like, wouldn't that be? No, that's, like, for the vector,
Yeah.
because,
Excuse me. Sure.
that is like, isn't that,
What's that going to give you? What does 150 and 40 give you? What are those two values? What is 150 kilometers and 40, and what is it?
40 kilometers.
40 kilometers. What are those values, actually?
The quantities
Are they distance, are they time, are they velocity? They're distances, right? And it gave you a time. So what has it given you? A distance where he's ended up over a given amount of time. Can I find the velocity?
Yeah.
Sure. So what it's given you is its ground speed. That's where it's located. Right? After a certain amount of time, that's where he was going to end up. So, what was it? 150 west,
40 kilometers south.
40 kilometers south. Okay? So let's find out what that is right there. So let's find out what his distance was. Kilometers, and how long did it take?
30 minutes.
Or 1/2 hour, right? So let's find out what his velocity was. How do I find velocity?
Distance over distance.
Distance over time. What's my time?
0.5.
0.5. So what is it?
620.96.
A little too high.
Oh, wait, I don't. Yeah. It is.
What's my distance?
155.242.5.
And I'm dividing it by what? Which gives me what?
310.484.
Good. Okay, so the only other thing I need now is that direction.
14.931.
West, 14.931 degrees south, right? Okay, so let's talk about this again. So, if we ignore this for a second, ignore the plane speed, what did it give us? It told us that after 30 minutes, this is where he was located. So, I was able to get this, which is my, whoops, that's nowhere near where I wanted to write it. Near my, this is my ground speed, right here. Okay, so I've got my ground speed, that's that guy right there, right? How do I get what my wind velocity is?
You take your plane speed, or your ground speed, subtract your plane speed.
Excellent, excellent. So, what's the first vector that I'm going to draw?
Ground
My ground speed. So I'm going to draw my ground speed. And that was 14.931 degrees right here, right? And that's about a ground speed of 310.484. That, correct? Now I have to draw the negative of my wind speed, or my plane speed. So how do I draw the negative of this guy?
240 east.
240 to the east. Perfect. Okay, so I'm just going to do this. I'm going to go velocity of ground 310.484 kilometers per hour. Okay, and then I'm going to draw east, you said? So I go to the tip of the first one, my ground speed, right? And I draw it this way. Correct? Not quite that long. There, should be fine. So, velocity of my plane was 240 kilometers an hour. We follow that? Because this is important. I'm getting it just from this guy right here. That tells me how to draw it. That is my instructions. The equation is used for instructions. The equation is not used for substitution. Okay? I don't substitute like I did in the previous units. It's used to show me instructions, directions, how to draw it. So then, where do I find my wind speed then? That there is my wind speed. Right? Okay so far? So what did I do? I drew my vectors out, my original vectors. Separately, nowhere near each other, not combining it.
Is there anything, just a second?
Sure.
You know, I followed through to help you at lunchtime. Turns out I forgot I have to.
Oh, okay. Yeah, no worries. Thanks. Thanks for telling me. Okay, so I got wind speed here, right? Everybody's okay with this? So now, if that's my wind speed, how do I solve to get it?
Cosine law,
Okay, well,
or sine law, I guess.
I don't have an angle.
It's 14.931, isn't it?
No, that's your other angle, you have to,
Isn't it?
Is that
Two parallel
transversal?
lines?
Yeah, you're right. So what do we know? That right there is 14.931, because those are opposite. The reason I draw these out, everybody, I draw these lines out on all of my vectors, those grid lines, is so that I remind myself every time that there are parallel lines, always. So that's right. Now I use my law of cosines, okay? And what do I get as my wind speed?
I got 70.48.
And now I need to find my direction of my wind.
You got 99.998.
Okay, so let's check this. So my velocity of my wind is equal to the square root of 310.484 squared plus 240 squared minus 2 times 310.484 times 240 times the
yeah, that's what I
cos
got too, I got 99.
of
0.999.
14.931. What do we get?
Oh, the answer to the book's 100, so.
Yeah, so I think me and Zach did.
Yeah, okay.
Yeah, no, I did.
Okay, so what did you get? 99.?
999.
0.999.
99.9 repeat?
Yeah.
Now,
No, it was
rounding.
99.998999.
So you would round to 9, 9. Okay.
Must be a 9 here.
Yes.
Yeah.
Okay, everybody's okay?
Yeah.
Alright, so now the last thing I need to do is get my direction that wind is. So,
Got 35.8. 0.83.
I got 36. 619. That might be wrong. Oh, that might be why.
What did you get, Casey?
I got 35.835.
I got 38.
I got 38.198.
Yeah,
You got 38?
Yeah.
Okay.
that might not
What
work.
am I doing? Let's see if that's it.
Oh, never mind. That's what I did. I did not.
Okay.
Just check over, maybe if
any questions here? Alright, again, another test question. Make a note of it, you're gonna see it again. Okay? This question, you may also use You may also use your components if you like components. It can still be done. I would have found the components of this guy, of my ground speed, okay? I would have found the components of it, and then used this easterly component, and then I would have done it on my table. So it can be done that way. But you guys have now worked with 2 units of law of sines and cosines in math, so here you have it. Okay? The last one I'll take a look at right now is the one that was on your question sheet. Done? Okay. You go. You just saw how to do it using that one. Go finish it right now. Okay. So, navigator of an airplane plans a flight from one airport to another 1,200 kilometers away in a direction 30 degrees east of north. So what is that? What did it just give us?
A distance.
Gave us the distance,
Wind speed.
the wind speed.
Later.
The wind speed is there, yeah. But in that first sentence, what do we get from it?
A distance and direction.
A distance and a direction in which the plane wants to end up. Correct? So if we assimilate that to velocity, what velocity is that actually? If I knew a time, right, what would it
The
be?
ground.
It'd be a ground velocity if I knew the time, correct? Because it tells you where you want to end up. So that's your velocity, that's your ground. So 30 degrees east of north. So I got it up here. I don't know it yet, right? That's what that is. It gives us a wind, correct? So the velocity of the wind is prevailing from the west, correct? All right. Let's look at this for a second. I want to go from here to here. That's the direction in which I want to go. The wind is blowing from this direction. So where do you suppose I have to aim the plane in order to end up here?
West.
Slightly west of it, correct? Do we agree with that? It's got to be somewhere up in here, right? I want that direction somewhere, because then the wind will push us over to here. Do we agree with that or not? Okay? So that would be what the plane velocity would be right there. What we want it to head. Got it? Okay. So I know the plane's velocity, and I know the wind. What I don't know is the ground. So here's what I'm going to do. I'm going to draw my, so again, let's go back to this. How do I find my ground velocity? Plane plus wind. Agreed? Yeah? So let's draw the plane's arrow first. All we know about that guy is it's 300 kilometers an hour. We don't know a direction yet, right? The wind is blowing this way. Again, because I'm adding vectors, tip to tail. Tip of the first, tail of the second. That's how we draw it. All right? That guy right there, correct, is my ground speed. Agreed? What's the angle from here to here?
30.
It's 30, which then makes that 60 degrees right there. Agreed?
Mm-hmm.
Everybody agrees with me on that? Yeah? So then, where can I put this in the triangle?
And the top corner, the right hand corner.
Top right hand corner right there. That's 60 degrees right there. Do I have enough information I can now solve to get my ground speed? Do I? Do I need anything else? What's the first thing that I can find?
The angle. Yeah.
Down here?
Yes.
Yes. So the first thing I want to do is I want to find out what that is right there. Because I have this angle, that side. This side, therefore I can find that angle. So using your law of sines,
$13.352.
excellent. Now that I have that, I want this angle right here so that I can find my ground speed.
106.648.
Lord, love it. $96.
106.648.
Okay. So that's that. Now, is equal to, what was it, 300 over sine 60?
331.890.
Kilometers per hour. Right?
Well, I did cosines and I got 331.891.
Okay. Again, it'll come down to the decimal places here. Okay, and that's close. I mean, if you're off by 1/1000, that's fine. All right. So this is what we have right now. Okay. So the first part of the question said, what direction should the plane head? So, in A, what direction should the plane head in order to end up where it's supposed to over here?
North 16.65 degrees east.
16.65 degrees east. Okay? Somebody give me another direction.
That should actually be 648. Not 65, 648.
Good, Marshall. What do we think?
East 70.252.
Awesome. Right? 100% right. Look at it.
Yeah.
Right there.
That's what I did.
Yeah, good. Awesome. Okay? There it was. Right? Then the question said, it started to compare the times now. Well, how far did he have to go?
1200.
1200. So how long would it take if I traveled at that speed?
3.6 hours,
3.6 hours,
roughly.
roughly. And then how long would it take if I traveled that speed with no wind?
4 hours.
4 hours. So how much time did he save?
4 of an hour.
0.4 of an hour, which is 24 minutes. Right? Yeah. that make sense, guys? There it is. This is the hardest question you're gonna get on the test. Also seen on the worksheet, also seen in the textbook. You guys get that? Okay? So, my point to you this morning is number one, okay? When it comes to the bike or the current questions, you find the time as if you go straight across and no current, no bike, no nothing. That's the first thing you want to find, right? The second thing you want to do, is in these questions is always work with this. Those are your directions, those are your instructions how to draw it out. Does that make sense? Those are the two things that you absolutely need to know for this test. Okay?